Wait, no. Okay, guys, here we go. 2.5, putting it all together. Number one. Place your answer on the line provided. Given the polynomial, there are how many terms in this one? Count them up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There are 5 terms. Okay, every term is separated by a plus sign or a minus sign. Number 2, the degree of the polynomial. How do I find the degree? Add up. No, you don't add them all up. You just look for the term with the highest exponent. And it's going to be 4. So the degree is 4. If there was more than one variable, then you'd add up their exponents. If it was like 4x to the exponent of 4 times y squared, then you add their exponents. What is my constant term? Constant term. 6. So the number without a variable in it. Okay. And the coefficient on the 5th term that you see here in this order that we were given. Coefficient of the 5th term. Oh, it is my constant. Whoops. Actually, no. Let's. It's just 6. There you go. Okay. Part B. State the constant of each. What's the constant in the first one? 7, or is it negative 7? Negative 7. Be careful with the sign as well. So you have to. If you see that minus sign in front, that also indicates what the sign for the constant will be as well. Second one, we have 8, and the third one, a constant is still a constant, even if it's not in a polynomial. Okay. Part C, which of the following is not a like term? Julio. Negative 3xy squared. Why is it not the like term? Because
y has been raised to the degree of 2.
The degree of 2, that's right. And x is the exponent 1. Okay. An expression that consists of 2 terms is called a binomial. Good. So these are the kind of short answer questions that you might see that appear on a quiz or the test. Okay. Give an example of a trinomial. So you can write any kind of trinomial you want. Make sure it just has 3 terms in it. So I can say here 2x squared plus 3x minus 6. So there's something with 3 terms. They all have they're all not like terms. Okay, they have different variables and exponents. F, an expression that consists of 1 term is called a monomial. 1 term, mono, 1. Okay. Part G, evaluate. Negative 3 squared. We have negative 9. So remember, the negative is outside that base. It's not the exponent does not operate on negative 3. It just operates on the 3, and then you multiply the negative afterward. The next one, we have it in brackets. So now we do negative 3 times negative 3, which is positive 9. Negative 5 squared. Negative 5 times negative 5 is positive 25. And then last one, negative 4 to the exponent 0, 1. Any number raised to an exponent 0 is always equal to 1. Express in power form using base 3. So how would I express the number 27 as a base of 3, Julian? 3 cubed. So 3 to the exponent 3. Good. 9, 3 squared. Good. And that was the last one there. Okay. So here's the part number 2. So for the rest of these, I am not going to do them all. I'll pick maybe a couple of them from each, and then I'll leave the rest to you for you to do afterwards. So expand and simplify. Let's pick something like D. Let's go down to D. Let's try and do D together like this. Okay. So expand and simplify. For this, you have to distribute. So distribute that number or the monomial in front of the bracket. So I'm going to take that 2, and I'm going to multiply it with the terms inside. 2 times A and 2 times 8B. So I have 2 times A. I'll put everything in brackets for now. Separate them by plus sign. So 2 times 8B plus. Then the next term, the next bracket here, I have negative 3 times 2A. And I have negative 3 times negative 3B. So plus negative 3 times negative 3B. Okay. Then I multiply everything out together. I have 2 times A, which is 2A. 2 times 8B, multiply those numbers, so I get 16B And minus 3 times 2 is net minus 6a. And minus 3 times minus 3 is positive 9b. Okay? Then I collect like terms. 2a minus 6a give me minus 4a. And 16b plus 9b is 25b. So plus 25b. Okay, and there's my simplified form. Okay, so expanding and simplifying means distributive property, and it means collecting like terms for the simplifying part. So let's jump down to the next question, next page, number 3. So the rest of number 2 I'll leave for you to do when I finish the lesson, okay? Number 3, let's pick maybe a couple of these here. So let's try, let's do 3a. So I have 3 powers at the same base, all being multiplied.
For an interruption, could Ms. Slowinska and Mr. Trainer please bring your classes to the cafeteria? That's Ms. Slowinska and Mr. Trainer to the cafeteria.
So I multiply all these powers. So what I have to do to do that is to write the base once, m, and if they're all being multiplied, then I add their exponents. So 3 plus 7 plus the invisible 1 for the last one there, okay? And when I add them up, I get m to the power of 11. Question? You can just do it in one step. So if you want to go directly from this to saying m to the power of 11, that is acceptable too. Okay, I only do the second step just to make sure everyone understands or remembers what's happening. Okay, let's do a division one. A to the exponent 19 divided by a squared. Again, you could do this in one step. Subtract the exponents if you're dividing. So 19 minus 2 is 17. Let's do now the third one. 2a to the exponent 4 to the exponent 3. So this one here, you can write it like this. 2a to the exponent 4 times 2a to the exponent 4 times 2a to the exponent 4. Or you could do it like this. You can distribute that power inside. So 2 to the exponent 3 times a to the exponent 4 times 3. Because when you're raising a power to a power, you're multiplying exponents. You're not adding them this time. Okay? 2 to the exponent 3 is 8. And a to the exponent 4 times 3 is 12. So a to the power of 12. Okay, and that's how you would simplify it. If you were to do it using this, then you're just multiplying everything together and you'll still get the same answer. All right, so I'll leave D for you to do. I'll leave, let's see what else I can do here. E you can do on your own. F you can do on your own. G you can do on your own. Let's go down to, I'll do I. Let's do I. Combination of quotient and power of a power. Okay, so which law would I do first? Do the one in the brackets first. So b to the exponent 15 divided by b to the exponent. If I do 3 raised to the exponent 4, I have to multiply them. 3 times 4. Okay, so again, b to the exponent 15 divided by b to the exponent 12. I just now have to subtract these two according to the quotient rule. And so I get b to the exponent 3. 15 minus 12 is 3. Okay, so that's a quick review of exponent rules. I'll leave the last two on that section for you to do on your own afterwards. Let's start jumping down to number 4. Okay. So this isn't the first time I asked you a question like this. There are questions where I ask you, find the mistakes. Which one is the correct answer? So you have an expression here that you're asked to simplify. This is like a communication or application problem. So you have to identify where the mistakes are or which student has the correct answer. So if you really know your rules, then you can evaluate it yourself. Okay, then you can see n squared times n cubed is n to the power of 5 raised to the power of 5 outside. And on the bottom I have negative 3 squared times n to the exponent 4. That's also being squared. Okay, and when I simplify this, I get n to the exponent 25 over 9 times n to the exponent 8. And then when I subtract the exponents, I get n to the exponent 17 divided by 9. Okay? Then you can compare which one who has the correct answer. So if I look at Debbie's answer, I have she does very much the same thing I did, except she kept the negative. Okay, she forgot to multiply the negative 3 times negative 3 again. And then all of a sudden she puts the negative 9 back up on the top instead of leaving it on the bottom. Okay. Cindy's answer looks okay so far, except the bottom here, 16, which should not be 16, it should be 8. Okay. And it results in a bad answer at the bottom again down here. So are they, they're both wrong. Okay, is either student correct? No. They are both incorrect. Okay, explain why. The reason why is because for Debbie, she did not do the multiplication of the negative 3 correctly. And for Cindy's answer, she must have doubled or quadrupled the exponent on the bottom to get 16 instead of 8. Or double, I should say double. Okay. All right, next page, number 5. Simplify the expression and determine its value in x equals negative 3. So first part, simplifying. Distributive property. Negative 8 times 3 is negative 24. Then I distribute the 8 with the minus 2x. Negative 8 times negative 2 is positive 16. So I'll write plus 16. Don't forget the x. And then I have minus 7 and minus 6x. Collect like terms. I'll start with the x's first. So 16x take away 6x is 10x. And then we have the constants. So negative 24 take away 7 is minus 31. Okay. So 10x minus 31. You're then asked to evaluate 10x minus 31 when x equals negative 3. All you do for this one is replace x with negative 3. Okay, think of those areas and perimeter problems that I asked you to do. What is the perimeter or what is the area when you're given an x value? So I'm taking x and I'm replacing it with negative 3, and I have to evaluate. Bed mass, 10 times negative 3, negative 30. Minus 31 is negative 61. Okay, does that make sense?
For an interruption, this is the last call for any grade 9s and 10s who have yet to submit their registration forms and fees. Please go down to the cafeteria. This will end the interruptions for this morning, and we'll do grade 11s after your lunch. Thank you.
Okay, number 6. I've given you a lot of shapes in that homework and in the handout from Friday. Okay, so again, I'm going to review some of these here. So find the perimeter. I'll do B and you can do A on C on your own. So perimeter B, all you do is add up the 3 sides. Julia? Yeah, go ahead. Add up the 3 sides. So I have 3x plus 7. Pretty simple. 3x plus x is 4x plus 7. And there's my perimeter. Okay. What about for A? What you're missing is the other 2 sides, 2 and x. Once you put those there, then you can easily solve that one. Okay. C is the challenging one. Maybe I'll do C as well. Is it challenging? What you're missing is this side, and you need this side. Okay, so let me label them A and B. So if I said this was A and this was B, how would I find A? That's good. 5m minus 2m. So if I take, so A is going to be 5m plus 1. I subtract 2m. This part here, I will get what's remaining, my A part. Okay? Because 2m is just the same thing as saying 2m up here. Okay, so A is going to be 3m plus 1. What about B? Three plus m. So this part is 3, and this part is m. Add them together, I get 3 plus m. So my perimeter is add them all up. Okay, going from starting from m here on the left, so m going clockwise plus 5m plus 1 plus m plus 3 plus 2m plus 3, and my a value is 3m plus 1, so 3m plus 1. Okay, so this part here is my a, and m plus 3, my b part is here. This is b. Everything else is given on the diagram. Add up all your like terms. M plus 5m is 6m, plus m is 7m, plus 2m is 9m, plus 3m is 12m, so 12 m's. And they have the constant value, so 1 plus 3 plus 3 plus 1 is 8. Okay, 12m plus 8 is my perimeter. Let's go down to area. Okay, again, I'll just do B. You can do A and C on your own. B is the triangle, area of a triangle. Base times height divided by 2. Okay, you're going to need to know this formula if I give you a triangle on the test. I'm not going to give it to you. Okay, my base is 2x. My height is 3x plus 2. So the area is 2x times 3x plus 2 divided by 2. Okay, you can make some reductions before you distribute, so I can divide the 2 from the top and the bottom. And all I have left is x times 3x plus 2. Distribute. X times 3x is 3x squared. X times 2 is plus 2x. And there's my expression for the area. Heard someone say what? Something confusing? What's wrong? Kyle? No? Okay. Okay. Next one. This is where it starts getting challenging. This is the kind of thinking questions that I might give you on the test. Okay, the perimeter of ABC is given by this expression, 5x squared plus 3x. What is the simplified algebraic expression for the area of the rectangle ACDE? So ACDE, area of the rectangle. So what I need for the area of the rectangle, area equals length times width. I have the width here. What I need is the length. So the question mark for the length. How do I find the length? You subtract by using the perimeter. Okay, so we're given the perimeter is equal to the expression that they gave us, 5x squared plus 3x. But we also know 2 of the sides. So I can say 5x squared plus 3x is equal to the sum of all 3 sides. So I have 2x plus 3x squared. And for the length, I'm just going to put an L to represent the length. Okay, we'll say the length here is L. So all I have to do is just subtract from the perimeter to find the L, find the length. So 5x squared plus 3x minus 2x minus 3x squared gives me my length. Okay, so you collect like terms. The 5x squared and take away 3x squared is 2x squared. So you just subtract the coefficients, but you don't change the variable in the exponent. 3x take away 2x is just a single x. And that's my length. Okay, so now I have my length. I have my width. I can calculate my area. So my area equals x plus 2 times 2x squared plus x.
We just found L. Something that
Okay. Can I go further in this last thing here? Does this look familiar, the area expression? You know what? It looks like challenge number 16, right? 2 brackets. Yeah, I'm going to teach you something, how to do this. Okay? It's called FOIL. Who said FOIL? FOIL? FOIL. Okay, I'll teach you a different way of doing it besides FOIL. Okay, this can be done using the distributive property. And all it is you take, guys, listen up. Take,
Ms. Garland, please go to the cafeteria, Ms. Garland, and you can please go to the cafeteria. Thank you.
you take, I'm going to do this in a different color. You take the first variable, first term I should say in the first bracket, and you multiply it with the first term in the second bracket. You take the first term in the first bracket, multiply it with the second term in the second bracket, and then you take the second term in the first bracket, multiply it with the first term here, and the second term in the bracket, and multiply it with the second term here. Okay? Via. AB is, did I make a mistake? AB is 2x squared. Oh, okay. 2x squared. So how does that change everything? Oh, that means this disappears, right? Yeah. Whoops. Oh, that makes the problem a whole lot easier then. Thank you. Okay, I'll teach you that FOIL trick another day then. Unless you want to, maybe hold on a second. Maybe I can do it now. So length is equal to x, which means my area is x times, where's my width? X plus 2. And if I distribute that, I get x squared plus 2x. Very good. Yeah, I guess I just must have missed that x squared there. Changes your answer, doesn't it? Now, well, let's see what else there. Okay, so why don't I show you, I'm going to just pause this for a moment here.